This would be the last example in determining the orbits of a certain permutation sigma. We are still on S8 because we have 8 elements here, and we are going to look for the different orbits that can be drawn from this permutation. Of course, you're going to use this idea for A and B, sorry for that, element of our A, or in this case, our S8. Let A be related to B if and only if B is a result if we're going to operate the permutation n times using the mapping from A for some n element of set of Z. If we're going to establish that certain elements are related to one another, they belong to a certain orbit, and they must be included in the same set. Because our orbits are expressed in sets, that would mean we could also rearrange the elements. But later, we're going to teach ourselves to really place, because of course, if it's a set, you can rearrange it, and of course, you can decide on your arrangement. Our arrangement must be in such a way help us later on if we're going to proceed to the next topics such as cycles and etc. So let's start with the mapping for 1. And since 1 map is mapped to 3, this means that 1 is related to 3 and vice versa, and they must belong on the same orbit. Okay, later we're going to place that. So if we're going to have the second mapping of 1, this just is equivalent to the mapping of 3, because if you have this expression here, let me just illustrate in this manner. 6, 7, 8. You have 3, 4, 5, 1, 2, 6, 7, and 8 here. Of course, we are multiplying sigma to itself. 3, 4, 5, 6, 7, and 8. 3, 4, 5, 1, 2, 6, 7, and 8. If we are going to have mapping of 1 to 3, right? But as you go here, because you're moving right to left, you'll now be starting with 3. Hence, the second movement or mapping for a permutation for 1 is just the same as this, because this is just the same as the given. So you have here 5. So aside from 3, 1 is also related to 5, and 3 to 5 as well. Let's continue. So 1, this again, 5. Let's be focusing here, 2. And then, that's 4. The n is now equal to 4. Okay. It's now the same as mapping of 2. So 2 map to 4. Then we still continue because we might have one more. You have here 4, and 4 ends up with 1. Once you return to this here, that's right at the end of the process, and hence your orbit will, in one of your orbits is this set containing 1, 3, 5, 2, and 4. As mentioned, you can rearrange them, but we just need to practice it like this so that we will not have any problem as we move further. So since 1, 2, 3, 4, and 5 are already done, 1, 2, 3, 4, and 5, let's proceed to 6. And since 6 is just mapped to 6, and that's it, we ended up here. You just end there. Okay? Let's proceed to 7. But 7 is also just mapped to 7. This is your orbit as well. And then, for your 8, 8 is mapped to 8. So you have here a separate set containing 8. We have 4 orbits here. You have this, this here and here. As you can see, as mentioned earlier, these sets are disjoint. They do not share any common elements. Because if we're going to combine them, 1, 2, 3, 4, 5, 6, 7, 8, they are disjoint. At the same time, when under the operation of union of sets, they comprises as 8 our original set. This is how we discuss or determine the orbits of a certain permutation. Thank you very much for watching.